Hello, everyone. I hope you can hear me. Can somebody just confirm if they're able to hear me or not? Okay, great. All right. So there is one question: is what is supervised learning and what is unsupervised learning? Okay. So let me give you an example. Okay. So machine learning is all about prediction, right? So what happens is in classical computing, right? What happens is you are given a problem and you know how to solve that problem, right? So this is a typical computer science problem, and you know the formula for that. So let's take an example that given a number, you need to find out a number is even or odd. Right? So you know the formula how to do that, right? You will divide that number by 2, and then you will see that if the remainder is 0 or not, right? So these are classical computer science problem. Now in machine learning, you don't have the formula, right? You are just given a problem, and you are given the solution of that problem. But no one will tell you what is the relationship between that solution and the problem. Okay, so let's give an example. Let's say I give you an image, and I tell you that okay, this image contains a cat, but you cannot ask me that how you figured it out that an image contains a cat. Do you have any formula? I don't have any formula. I just use my human intelligence. I used my eyes to identify that if there is a cat, I will say that this image contains a cat, right? So in machine learning, what happens is when you are given a set of a data set or set of data along with its class label. So in this example, the data is images and the class label is nothing but what that image contains, right? So let's say cat or dog or animal or human being, whatever. And then you have to build a model, right? Where you have to come up with an algorithm with using some machine learning algorithm. You have to come up with a model such that once the model is trained, if I give an image to that model can predict what that image contains. Okay, so in this definition, we are dealing with supervised learning, because before you started the training, when I gave you the data set, I gave you the data set along with its class labels, right? I have given you, let's say, 1 million images, and I will also give you 1 million labels of those images. So you have the data and the output or the labels, and then you build a model based on some supervised learning algorithm. So this is called supervised because you are I'm supervising you by giving the data set along with the label. Okay, and then we have some problem where class labels are not given. We are just given the data, right? One of the example would be, let's say, I give you the details of uh, uh, people who stay in India, right? I'm not giving you any other information, but I'm just giving you the details of people who are staying in India. So maybe age, name, gender, professional, status like students or working people or whatever. And then I'm telling you that, okay, can you figure out some common features across all these people? So then you can do something called clustering, right? Basically, you will take the data because you don't have any class label, right? I'm just giving you a data, of all the people in India. So you have to use some of the, unsupervised machine learning algorithm to find some commonality or some kind of segmentation. So you may have some cluster of people who are, let's say, a working professional, or who are students, or who are kind of retired people, but you have to figure it out, right? And then you can give me, okay, Suman, this is the data that you gave me. I have created a cluster based on this professional statistics. Okay, or you can do a lot of other things. So these are very much used in e-commerce companies, unsupervised learning, where these companies, what they do is, you might have seen if you have shopped in Amazon.com, you might see some email that you see get from Amazon saying that, okay, there is some sales going on in this electronics category. Would you like to check it out? Do you feel that email is received by everyone on this planet who have an Amazon.com account? No, right? They will send that email only to people who have purchased history in electronics category, right? So what Amazon or what any e-commerce company would do typically is, based on your shopping patterns, right? Based on everyone's shopping pattern, they try to make some clusters based on their nature of shopping. So maybe someone is interested in electronics, or someone is interested in books and all of that, right? So based on that, they send out some promotional email to different set of people, right? So this is called unsupervised learning, when you were just given a data and you have to figure out some common characteristics or some commonality within the data. So there are a lot of algorithms of unsupervised learning we have, like principal component analysis, right? These are the clustering, the various clustering algorithms, right? So these are unsupervised learning. Okay, so let me know if you have any follow-up questions. We can discuss, and let me move on to the next question. Do you think that AI ML will create more jobs than it will replace? Okay, that's a great question, Nina. So I feel that yes, it will create a new set of opportunities, and it has already created, right? And in the upcoming days, it will be much more, right? So if you think about it, right, a lot of things that we were doing, manually, or rather, I would say, in a very rude way, right? But now we are using machine learning to see that how we can leverage that and do it in a smarter way, right? It's not about replacing. It's all about how smartly you can do it. It's not always needed to have machine learning in all the problems, right? There are a lot of places where you can do solve problems without even machine learning, right? We don't have to complicate things by using some fancy technology just for the sake of it, right? But if you see, there are few problems which were not possible to solve before this machine learning thing came up, right? If you think about it, these days, we go to airport with just our face. We are able to check in, right? We have it in Bangalore airport, and there are many other airports across the globe. So think about it. If you have to do this, like image classification or image identification of, or any facial analysis, these are very tough problems, right? Any image, any computer vision problem is a very tough problem. If you have to do it without machine learning or AI or deep learning in particular, it's very difficult, right? It's almost, it was next to impossible, 10-20 years back. And over the period of time, we could able to solve that. So it's, AI is all about solving the problem which we never thought that we can ever solve. And obviously, in our existing day-to-day work, there are a lot of places that we can use machine learning to make our work more efficient, right? And that would create a lot of job. And in fact, there are many openings around, and it's not only about machine learning and AI, but also in data analysis or data science, or there are a lot of auxiliary thing around this whole ecosystem. So we all have some opportunity to work there, right? Okay, so is there any other question? Okay, what is the difference between machine learning and deep learning? Okay, that's a good question. I should have added that in the presentation itself. So basically, you can think of it as machine learning. So AI is a bigger umbrella. Under that, you have machine learning, and then inside that, you have deep learning. So AI is all about the concept or the system. When we think about from application standpoint. So let's say if I give you an example, automated car. So that's an mission which we want to achieve. That means today I drive my car, but if I think that, okay, I don't want to drive, I just want to sit back and I want the machine to drive the car. So this would be an application of AI, or I want, what basically I want is, I want a car which is AI enabled. That means I want that car to think or the driver to think like a human being. So that is what AI is. Now, let's go deeper. So this is kind of a philosophy or the end objective, right? But now how to do that? So that means now I have to, write the code, or I need to make a system which can think like human being. So for that, I need to have use machine learning algorithms. I need to use sensors. I need to use images, etc., etc. A lot of things I have to use, and then I need to process all of that. So I need to have some machine learning algorithm to do that. So there comes machine learning. So AI is a bigger umbrella. You can think of it as a whole universe, and then inside that, how to practically implement those AI objectives that you may have by using statistics and machine learning and mathematics is all about machine learning. Now, within machine learning, there are different types of problem and different types of categories, I would say. And one of them is deep learning. So in deep learning, what happens is, it's mostly when we think about deep learning, we think about images, and we think about very complex problems. Okay, so it's like this. In machine learning, um, you are given the data sets, and you have to do the feature engineering. Like when I give you a data, or let's say in an Excel sheet or a CSV format, you have to, before you pass the data to your machine learning algorithm, you need to figure it out which features are important, right? And which data is relevant and all of that. And after that, we call it as a feature engineering, and then you will pass on that data to the machine learning algorithm. But in deep learning, what happens is, when you have some problem where selecting features or what is the right feature, it's very difficult to figure out. For example, let's say I give you an image, and if I want to ask you, you build a machine learning algorithm which can figure out an image contains a cat or not. Now it's very difficult, because when you get an image, how you will find out the features. So you have your thought process would be, okay, what are the features of a cat? It should have a ears, and then it should have a tail and all of that. But again, we have lots of different types of cats in this world, right? So you cannot just make a generic feature for all the cats, right? So you want machine to figure out common patterns and features of the image, right? Or rather, in this case, a cat. So there we use deep learning, where we don't do that, feature extraction. The machine learning algorithm, or in particularly deep learning algorithm itself, figure out the pattern. Okay, so this is the difference between kind of a difference. I mean, there are many more sophisticated difference, but there's one of the difference that you can think of, or the intuition that you can get from here is deep learning is used in the area where extracting features and patterns are very difficult when you get the raw data. Okay, and if you want this system to figure it out for you, or the algorithm to figure it out for you, there we use deep learning, where you have deep neural networks where each layer extracts every feature. Okay, and it's keep on going one after another, and then finally you get the output. Okay, so let's move on to the next question. What should you learn for AI or machine learning? Okay, that's a good question. So as far as the learning is concerned, it all depends on what is your background and from where you are coming. But I want to make sure make it very clear that anyone can learn AI ML. Okay, so there might be a different starting point for every one of us, but it would be all same for, I mean, everyone can join. It's not like you have to have a very math heavy background, or you need to be a computer scientist or computer engineer or software engineer, not like that. Okay, so let's assume that you have no background. Okay, and let's assume the worst case, you have never did any programming as well. So what I would recommend is, maybe you can start learning a basics of programming if you are new. To pick up a language, I would say Python or maybe R, but mostly these days, almost 99% of the thing that we do across the globe is on Python. So Python should be the starting, language that if you want to pick up a language for machine learning. But if you are comfortable with other language like R, you can go ahead with that. But predominantly these two languages, and then gradually while you are learning Python, you can just focus on basics of Python. You don't have to think about what are the modules and things that you need to learn for machine learning. I would never recommend that. First, just learn that language, okay? And then you can give a little bit of time to learn a very basics of maths and statistics. Very basics. You don't have to get too deep, because once you get too deep, you will get demotivated, and you will end up thinking of learning machine learning before even start learning it, right? So just have some basic understanding, like what is probability, what is conditional probability, and all of these things, right? What is mean, standard deviation, what are some of the distribution, basic things. And few things you may not understand, just take it for granted at that point in time. And then you can start off with machine learning basics, right? So maybe supervised learning would be the first thing that you would encounter. And one small thing, when you try to start with mathematics or statistics, you may like to explore a little bit on linear algebra. It's very, very important, because it's all machine learning, it's all backed by that. But all those things, spend little bit of time, and just to get a feel of all the terms. And then you can start off with machine learning, supervised machine learning, and then unsupervised machine learning. You can pick any resource. There are hundreds, thousands of resources available. If you want me to highlight, you can ping me over LinkedIn. I'll be more than happy to share a few of the resources. But you are smarter than me. You can find any good resource, and whatever resonates you well, just pick that up, and then you can move on with deep learning or whatever area you want to focus. All you have to do is, first 5-6 months, is you need to figure out what interests you the most. If you're more interested into computer vision or deep learning, you can focus there. If you're more interested in maybe statistical analysis, or building models for traditional machine learning problems, you may like to focus on machine learning itself, classic machine learning. So it's all about what you really want to do, right? And a favorite programming language, so I would say in machine learning terms, it would be Python. And I guess if you ask this to anyone, everyone's answer would be the same. Yeah. Okay, what should be the path for AI for highest demand? For example, computer vision and data science. All right. Yeah. So I guess this is similar to what I just mentioned. You can pick up, machine learning and basics of machine learning, linear algebra, mathematics, and all of this, because this would be needed anywhere, anywhere you do, or whatever you do in machine learning field. Now, when it comes to deep learning or computer vision in particular, this field is changing very drastically in last 10 years or so. So if you think about it, this deep learning thing, kicked off from 2012 onwards, and every day it's changing. You pick up any classic deep learning book, you will find a lot of things like CNN, recurring neural network, or GPT. These days, the latest one is GPT-3 and all of this. But what happens is, in this field, in deep learning field, a lot of things have become obsolete, kind of like LSTM, RNN. These are there. If you pick up any course or any tutorial, you will find all of this. But when you go in the practical field, you will find that no one is using that, because this field is changing so drastically that you need to keep up with the pace. So this is an evolving domain, and I would say that for deep learning specifically, for computer vision, you may need to explore more. Like, you can pick any course, any book, but while you understand all these basics, you need to also focus on what are the new research papers have come up, and what they are talking about, and try to implement that, right? So because basics is always the same, right? It just, new technology will take a new curve, right? Especially in the field of NLP or GAN, as we have today. So yeah, so if you are into computer vision and deep learning, make sure that you are part of various forums where you get all this new information, and yeah, you can pick up the area of your interest. Okay, so next question is, how do you see the progress of machine learning in next 5 years? Do you think that it is sustainable, and will it be able to adapt? Okay, see, I'm not the right person to say something which you should take as a gospel, but as a colleague or as a friend, I can tell from my perspective, based on what I've seen in last 1 year or so at AWS, and also in general. So machine learning has created a lot of opportunity, and I cannot think of doing anything right in our technology space without machine learning. It's not about sustainable or non-sustainable. I don't see it feasible, right? Because the kind of maturity or the kind of comfort that we are enjoying today in the technology stack, it's all driven by it's not all, but it's driven by or powered by machine learning. Just think about it. Like we use in India we have Ola cabs, but we have online cab services all over the world, right? So just think about it. Is it possible that if they stop working, or they don't find you where you are in, and all of this, will you be able to sustain, or will you be able to live your life as far as the commute is concerned? Surely not, right? It would be difficult. I mean, obviously we lived before that era as well, but just think about it. The kind of recommendation that you get while you go for shopping, online shopping, or while you order some food in via some app, it's all driven by machine learning. All right. So I see that going forward, we will find a lot of more opportunities. Like today, we have drone services in few of the areas where you just order and you get the product with an air drone. All right. So just think about it. I never thought this when I was in college, that even this is feasible. But now we are living in this era of advanced technology. So going forward, we will see lot many other exciting things. Yeah, but surely everything has a hype curve, or everything has their up and down. But what I feel is, if if we don't see machine learning or deep learning, which it's very unrealistic thing, we'll have something which is on top of it, right? We'll have something else. God knows what it is, but it will be always something good for human mankind. Yeah. Okay, so does machine learning, deep learning can beat the ability of human brain? That's a very good question. I think there are a lot of people, humans are only making these machines, but the thing is, machine has a, has a persistent memory, I would say, right? So we already have and human robot, right? Sophia, if you have, if you have not checked, just check this after this conference. We have Sophia, which is kind of it's a AI-based robot, right? And which got the I think citizenship from one of the country. I forgot, but we are going in that direction. And the whole idea of machine learning, and in particularly deep learning and all of this and AI, is to make machine who can think like human being. That is the whole objective of the whole machine learning fraternity, right? That we want to make system who can think like human being. Then we can do wonders, or we can do the worst thing that is possible, right? So it's always a double-ended sword. But yeah, that is what a lot of people in research are going on in those fronts, right? And we are there in few of the areas as well. So that's why we have automated car, right? Which you can think of it as we are trying to replicate a human brain, right? So also, does that mean that the automated car works fine? Surely not, right? They all have plus minus, but over the period of time, we expect that it would evolve, right? Yeah. Okay. So, all right. Any other questions? Very good questions, and feel free to reach out to me over LinkedIn. I'm quite active. I check my messages almost every day. So if you have any questions or concerns, or you want to get started, or if you are into AWS, if you get stuck anywhere, just feel free to ping me. I'll love to share my inputs, right? Yeah. Okay, so one last question. What is the overview, challenges, and limitations of machine learning? Okay, so there are, to understand the challenges and limitations, I need to understand machine learning to that extent, right? I'm still not there, to be very honest. But I would say that the only challenge that I feel is, it's this field is very evolving. So by the time that you get hold of something, right, something else come up, right? And one of the thing in machine learning is, I mean, this is from learning standpoint, from practical implementation or from real world standpoint, in machine learning, since as we were just discussing a couple of minutes back, since we don't have a formula to connect the data with the labels, right? Let's think about supervised learning. We need a lot of data to build a very good model with high accuracy and all of that, right? So we need data. Now we have data. It's not like we don't have data. We have plethora of data, but I see that these data are in very rough format. So in machine learning field, I see that we have lots of challenges to prepare the data to a level which we can use for any machine learning training. So I feel that over the period of time, we will have more structured way of storing data, and that way our pre-processing time would go down, and we can focus on solving the actual problem. So today, if you pick up any real world problem, and if you are given the data, you will spend 90% of your time, if not 90, roughly 70% of time, to make the data in a presentable format for your algorithm to use. You cannot just give junk data to your algorithm. It won't find anything meaningful there, right? So I think that part we need to work on, and there are a lot of techniques that is coming up over the last couple of years, and many years. So yeah, so I think that would be something that we need to work on. Yeah. Okay, great. Thank you so much. And if you have anything, just reach out to me over LinkedIn. I would love to hear from you, right? If you have anything positive, then you can share with the whole world. If you have anything negative, then message me personally. Okay, just kidding. Yeah. So just reach out to me if you have anything. Thank you so much for your time, and have a wonderful event and weekend ahead.